Today, we're going to go over the rules and formulas that we commonly see on the SAT, as well as just a quick overview about the digital SAT test and what you can expect on there. Now, there are quite a bit of formulas that we're going to go over today. I think that the formulas problems are probably the toughest ones because there's so many different formulas to go over. Um, the rest of the courses typically are a little more refined and we go over just maybe a few topics at once. That being said, the rules and formulas sheet that you get on the SAT is very valuable to you. You can always access that and look at those formulas if you need help with common formulas mostly related to geometry. I'm going to share my screen here. We're going to go over just very quickly what the test is about. So the test is broken into different modules. You can sort of think of it as an easy section and a difficult section. So the first module, um, there's 22 questions. There's also 22 questions in the second module as well. You have 35 minutes per module, which gives you about a minute and a half per question. So these are all multiple choice. They're going to be in a mixed order. And the easy ones are going to be first, and then the harder ones are going to be afterwards. Um, there are some word problems in here. Um, the word problems, they can be a little bit tedious sometimes. So just be careful with the wording. We'll go over this when individually when we look at specific questions together. You get full access to a calculator on the exam as well. And I believe you can also bring your own graphing calculator if you want to. I would really suggest, um, I would suggest familiarizing yourself with Desmos. We're going to go over Desmos several different times in this course as well. So you take module one, they calculate your score, and then they decide based on that score, are you going to do the A questions or the B questions? When you get the B questions, they're a little bit tougher questions, but you get an extra 100 points by scoring into the B section. So it weighs out that average for you. You can also see the time. You can mark questions for review and go back to them later. The reference sheet is the formulas that I was talking to you about earlier. Let's see. You can leave a note to yourself if you want to. Remember, you just have a minute and a half though for each question on average. Okay, so that's an overview of what the test is about. We're going to go over some strategies next for the SAT. So I would say that the best strategy for all the questions in the SAT, if you are stumped and you don't know how to start the problem, or if you think to yourself, I know how to do this problem, but it's going to take me more than a minute and a half. Plug in your answers. That's the first thing that you can do. You can also pick a number and plug in a number to help you get an answer. I would suggest not using 0, 1, or 2 for picking a number. 3 would probably be a good idea. 5 is usually an easy number to work with. You can think in multiples of 5 a little bit easier. So that's a number you could use. If we're talking about tables or graphs, you can use a point. So you can use a random point, and you can plug that in to see if that fits the answer. And then finally, using the Desmos graphing calculator. That's going to be your best tool whenever we have graphing problems or even table data that we can look at. So again, if we have an equation, rather than solving the whole equation, we can plug in the numbers for that equation. Let's take a look at a quick example here. We have x is equal to the square root of 15 minus 2x. And it says, which of the following represents the solution set to the above equation? This basically just says what does x equal? So it says 3, -5, or -5 and 3. And so for this one, we would just quickly plug in -5 and 3 because that's what C is. It wants us to check both of those. And then A and B, that covers A and B as well. So we're going to plug in -5 and 3 for these and see if it makes a true statement. Here, if we plug in, let's see, our original is x is square root of 15 minus 2x. Let me just write that right here. Just for our reference. Okay. So we plug in -5 for this. We have a double negative here. This becomes plus 10 square root of 25. And the square root of 25 is 5 and -5, but because it's also positive 5, -5 is not a solution for this. So anytime we do a square root, it's plus or minus. But it has to be both for this. So this one, square root of 9. Actually, it looks like they just did the positive roots for this one. The square root of 9, 3 is equal to 3. Yeah, let's not worry too much about that plus or minus detail with these problems here. So 3 equals 3. This is a true statement. -5 equals 5. That's a false statement. So we can cross that out. So our only answer is 3, which is, if you go back up here, it's A. So the key takeaway here, plug in your answers, or answer choices, and see if that one fits. That'll save you a lot more time than if you were to say, okay, let's square both sides. We get x squared equals 15 minus 2x. Now we have a quadratic, and we have to solve with the quadratic formula. That can take a little bit of time. You could graph this and put this in Desmos as well. We'll go over that in just a moment here. So pick a number. So it says avoid 1, 0, 1, or 2. Try 3. I like to use 5, but here I think they did 3. So it says, which of the following is equivalent to this expression up here? We want to figure out what is equal to that expression. Well, we have a lot of different choices here, but what we can do is first we can set all of these equal to the original expression. So here's our original expression, x minus 5 over x plus 2 plus 1. And we're going to set that equal to each of the answer choices. And that's what we have here so far before we plug in any values at all. Now, actually, 1 second. Actually, they did not. Looks like they plugged in some values already. So let me just write out what A would be, and then I think you'll get the picture for the rest of these too. So here's what A would be. We would set that equal to this, and we're just checking to see if A is a match. This problem is probably going to take us more than a minute and a half. So if we plug in, I'm going to plug in 5 actually for this. So now this is for A. Now our new equation is 5 minus 5 over 5 plus 2 plus 1 equals 5 minus 4 over 5 plus 2. All I've done is I picked a random number for x and I plugged it in. Now, if we plug in the same number for x, it should give us a true statement. 5 minus 5 is 0 over 5 plus 2 is 7 plus 1 equals 5 minus 4 is 1. 5 plus 2 is 7. So now this says 1 equals 1/7. And that's not a true statement. So now we can cross off A. And we would repeat this pattern for the next 3 of these. If we go back to the examples here, how they did it, they plugged in 3, and it looks like that worked for answer choice C. So we plug in 2x minus 3 over x plus 2, plug in 3 for x, and we get 3/5. And when we plug in 3 for our original equation, we also get 3/5. So if you look at the left side of this, we got, let's see, for A, we got 1 for the equation that it gave us when we plugged in 5. So that means that we should get 1 when we plug in 5 for one of these 3. Let's check to make sure that C is correct. Sometimes these answer keys are incorrect. Most of the time they're correct though. So if we plug in 5 for C, we should get 1 also. That's 10 minus 3 over 7. 7 over 7, and we get 1. So you can use 5, you can use 3. This is how they did it with 3 here. Okay, using a point next. Picking a number is a great way to find the right answer for this, especially when we're looking at graphs. Now you can plug all this into Desmos if you want to. If you're feeling a little unsure and you don't want to do the pick a point, you can plug into Desmos. But here, if we pick 0, 2 as our point, 0, 2, and I'm going to pick one more point. I'm going to say 1, 0, because really I don't like using zeros and ones. Or excuse me, 1, 5, 1, 5. I don't like using zeros, ones, and twos because sometimes it's a coincidence that we get a true statement. So if we plug in, here's 0, 2, 0 for x, 2 for y, 1 for x, 5 for y. So if we plug in 2 for y, 1 for x, let's check what that would be for a. You get 2 equals 2 to the 0. Anything to the 0 is 1. And so for a, we get 2 equals 1. And that's not true. So we can cross out a right away. If we go to b, do the same thing. 2 equals 4 to the 0. That also says 2 equals 1. And that's not true. For c, we can say 2 equals 2 to the 0 plus 1. That's 2 equals 1 plus 1. 2 equals 2. That is a true statement. Now be careful. You might jump and say, okay, that's our right answer. Remember, we're using the zeros and twos. Those can be coincidental numbers. So let's check 1 and 5 for that one also. So now we're going to plug 5 in for y and 1 in for x. Now we get 5 equals 2 to the 1, 2 to the power 1, which is 2, plus 1, 5 equals 3. And that's not a true statement. So C is not correct either. Now for our last one, hopefully D is the right answer. We're going to plug in 2 for y, 4 to the power of 0 plus 1. You get 2 equals 1 plus 1, 2 equals 2. That one checks out for the point 0, 2. Now let's look at 1, 5. 5 for y, 4 to the power of 1 plus 1, 5 equals 5, and D is the correct answer. Now for this one, you might be thinking, hey, I know how to use Desmos. I know how to use my graphing calculator. Definitely do that if that works better for you. We're going to go over Desmos stuff. Let me see here. We're going to go over Desmos stuff in just a little bit here. And again, we're going to go over Desmos throughout this entire course. But using the Desmos graphing calculator, you just go to desmos.com/calculator. And you can also go to desmos.com/scientific if you want just a regular scientific calculator to work with. So this has let me just show you. Let me share my screen on Desmos instead. So when we go to desmos.com, this is what it looks like. We can graph different functions on Desmos. Let me make this a little smaller. And actually, let's go back to this one that we just looked at. And let's see if we can answer this with Desmos. See if I can make it so we can fit all of this information on one window. Might be a little tough to fit everything on there. I'll do my best to make some room. Okay, so I'm just going to type all these equations then. 2 to the x. You can press Shift 6, and that does the exponent. Make sure to press the right arrow key to go back down if you need to add other stuff. If you don't, and you add stuff, sometimes it'll like add it on the exponent, but not always. Y equals 4 to the x. Oops. Y equals 4 to the x. Next one, y equals 2 to the x plus 1. Y equals 4 to the x plus 1. Okay, so here's our graphs. And we want to see which one matches. So it goes through 0, 2. So we got to figure out which colored line goes through 0, 2. Well, so far, purple and green. One of these two. That's C or D. So we can just click these, and then that turns those lines off. We don't have to see those anymore. And then 1, 5. You can type in 1, comma 5. Just make sure you put a space between them. And it'll show you the point there, and it looks like it's on the purple line, and that's D. So if that saves you more time, definitely you can answer your questions this way as well. And let me see if this is the part where we go over the tables. Okay. So here's a Desmos question. It says, here's this function f of x equals all this stuff. And it tells us the x intercepts of the function. So if you're familiar with polynomial functions, if you set each of these equal to 0, you can solve for what x is, and that tells you where it crosses on the x-axis. But this question is not really asking us that. All it says is which table shows us this here minus 3. So let's make a table for this, and we'll figure out what that is when we subtract 3 from it. So I'm going to close all this. When you make a table, you just press, actually, let's type the equation in first. So f of x is like the same thing as y. It's just another way to write it. X minus 4. Okay, so we have that there, and this is our function. Shows us where it crosses on the x-axis. If you set these individual parts that are in the parentheses equal to 0, it'll tell you where this crosses. But this wants us to match the table. So we're going to make a table. Click on the gear, click on Create Table. Now it looks like our x values for our answer choices are all the same, thankfully. So it wants to know x is -6, x is -5, and x is +4. Okay. I'm going to delete the rest of these. And that's the information that we have so far. You can also change the color of this. You can click and hold, and you can change the color. You can make them different icons if you want to label lots of different things at once. There's other neat things that you can do on here. But okay, so this is our table. So if it said which table is the function y equals f of x, then it would be this table here. But we want to know, what is f of x? Let's see if we can try to type this in. It might let us, it might not. Okay. We want to know, what is f of x plus 3? And that just means whatever this is, we're adding 3 to it. These are all 0, so we're going to add 3 to them, and it's just going to be 3, 3, 3. But you can also type plus 3 there for f of x plus 3 to get those 3's. So that one's going to be answer choice D. All right. So we're going to pause here, and I'll let you guys go ahead and start the practice.